Okay. Hello, everybody. My name is Vasileios Karakasis. I'm currently the group lead of the Scientific Computing Support Group at CSCS, and I'm also the lead developer of ReFrame. Before starting, who of you have heard of ReFrame or have played with ReFrame already? Okay. ReFrame is a framework for writing regression tests and for running regression tests on HPC systems. Our focus is more on the actual how you run tests and how you run them in the whole runtime and how all this is handled. Sandeep did a very good presentation, so I think now you can see also how they are a bit orthogonal in some aspects. Here are the mailing list, the documentation we want to be looking at, the GitHub repo and our Slack channel if you want to register. So why regression testing? So we are all here because of EasyBuild, and we know why the software stack is highly complex. It's not only complex in building, but it also has lots of implications, and all these dependencies might have implications also in the performance, perhaps, and little changes, even in the system or even in the library, can lead to performance changes, bugs, whatever. So how do you know that after even an innocent system change, the system that you give back to your users is sane and is performing as it ought to? The user experience is unchanged. And the other question is how we can make this sustainable, and also in the sense of how we can increase perhaps how often we do upgrades. And we need also consistency in our tests, also to be able to maintain them, and of course to automate the whole process. From when you push a recipe, you need to know that the recipe in your software stack repo, that it works correctly, and for example, the new version of GROMACS performs as the previous one, or even better, and so on. So all these are the key questions about regression testing that ReFrame tries to contribute to. So let me give you a little background. What was the situation? We have had, when I arrived at CSCS 5 years ago, there was a regression testing framework or suite that was essentially shell script based, and there were several problems to that, apart from the fact that it was shell script based, but the tests were very tightly coupled to the system details. So for example, every test, every writer, there was a kind of a backbone thing that was kind of driving the test, but then every test itself had to talk to the batch scheduler, had to submit the job, had to check that the job was correct. So you can imagine everybody was writing his test a bit differently, and then there were lots of little problems that he couldn't handle. There was a lot of code replication across tests. Essentially, at the beginning was about 15K lines of test code, the actual tests, and the coverage compared to what we achieved later was really, really low of what we were testing from the system. The other thing is, with even simple changes required significant team effort. I remember in 2016, we moved away from the Alps parallel job launcher from Cray to native Slurm, and I remember the whole team working for a month to port the test and fix little bugs that were replicated in every test. So I was really not going to evolve and scale. So this is how we came up with the idea of starting a ReFrame. And the good thing about it was that we have seen the problem of regression testing, and also how an implementation of it that didn't fit essentially our needs. So we knew exactly and had clear goals at the beginning. So ReFrame is essentially a framework that allows you to write portable HPC regression tests that they are written in Python. And by portable, I mean that you can transfer one test to the other system with very small changes. It also abstracts away, and it achieves that because it abstracts away the system interaction details, so you don't have to know about schedulers, module systems. You have to know just the logic of your test. And another thing is that it provides a runtime for running your tests, and you can run them serially, concurrently, and we're going to see how all this is. Here I have put, I mean, you've seen that from the SPAC presentation as well. You're probably going to see a similar slide from Robert's presentation later this day, where they said, I took the idea from Robert when I've seen his Excel presentation. Actually, this is the last 3 months of who is actually looking at the documentation now. They might be using it and searching for stuff, or just they're curious about it. But apparently, I know several users, and I'm going to show some use cases also in the US and also in Europe. So, since we knew the problem from the beginning, we had very clear goals. One was productivity. We wanted to be easy to write tests. We wanted to engage more the teams, the user support team and the sysadmins to write tests. With the previous, if you asked anybody to write a test with what we had previously, the answer was no. I mean, I can't do that. It's too complicated. The other thing was portability. We had several systems in production, and we didn't want to rewrite the test. For example, a Hello World test that tests MPI, OpenMP, or an affinity test, or things like that. We don't want to write them from scratch for every system. So we wanted to be quite easy to port them. Speed and ease of use. This is a thing that when we needed the command line interface to be intuitive and to be easy to use from the sysadmin team, because when we have a maintenance, usually they arrive quite early in the morning and they have to run ReFrame before to check that the system is sane, and then maintenance might go through late in the afternoon. Well, our group is a bit lazy in that aspect. We're not going in maintenance days like at 7 a.m. and leaving at 8 p.m. So we want the sysadmins that they're actually doing the maintenance work to be able to, with a command line, just test the system and give them a report, and just then contact us. Okay, guys, this is failing. Is it critical or not? And have a look or retry. And then robustness. So this is this project started from an empty Python file, and that was good in the sense that we didn't have any technical depth. So we started immediately with a test-driven design. So actually, if you look at the code, there's a very, very high coverage. So in GitHub is like 91%, but in reality it's even more, because we do some additional tests about schedulers and module systems, which we can't do them in Travis right now. Perhaps I want to contact Shazib about this thing. Well, line coverage doesn't mean that your code is semantically correct, but at least you know that there are higher chances. But we really invest a lot. We have invested and we still invest a lot. Nothing gets into the master if there's no unit test. So I'm going to go quickly through some key features. We support cycling through programming environments. You can view that as tool chains in EasyBuild's terminology. My terminology is a bit Cray-oriented, but the tool has nothing to do with Cray. It's not Cray-specific. And system partitions, that means that you can write your tests, and then ReFrame will go through the different tool chains that you define in your configuration that you want to test. For example, GNU, Intel, PGI, etc., etc. We support different workload managers as backends, parallel job launchers like MPI Run, MPI CSCS Run, a lot of them, and module systems, tmod, all the versions of tmod. We had the request, I'm not going to say from which center, that they were using tmod 3.1, and you would suppose that it's like tmod 3.2, but it's not. It's worse. So tmod 4 and lmod. We support functionality and performance tests and logging of the performance results, support for test factories. where you can write your test and then just generate, based on a parameter, multiple tests out of it. We support seamlessly now container runtime, so you can say, this test is, to run this test, use that container, and then that Docker container or that Singularity container, and it's gonna pull that container, mount the stage directory of ReFrame into the container, and then run the task inside the container, which is a nice feature. Support of test dependencies, that's a very new feature where you can define dependencies between your tests. We support concurrent execution of regression tests. That's a feature that has been along in ReFrame like for at least more than about 2 years now. We give progress in the result reports, and we have done lots of work in performance logging that you can, with different handlers, that you can send logs to syslog or Graylog or just to a file. And the other thing is that the internal APIs are quite clean. That also helps us to refactor and improve the internals of the code several times without changing external APIs, but also allows the easy extension of the functionality. Here is how the architecture, very abstract way of the architecture. So here is where the API of writing a test, and actually you don't, these do not talk directly to the OS. There is some environment and system abstractions, and there's different plugins that they actually plug and implement those interfaces, and then they're actually doing the actual interaction with the OS. Then there's the front end that actually drives the whole execution of the tests, and the runtime that is responsible for running the tests and keeping track of their progress. So at the heart of ReFrame, there is what we call the regression test pipeline, which is essentially these 6 stages. And this is the backbone. This is how every test has to go through all these phases, even if they do nothing. But this helps us also to do a better design that also reason internally about how things are working in that, but also help you reason about your test, because you can intervene in different phases of the pipeline. So here is how the serial execution policy is. Essentially, it sets up the test. It is just doing some environment checks. Then you build a test if you have to build it. Not all tests are build tests, so this can be skipped in some tests. Then it is run. That is, if it is either run locally or it is submitted to a job scheduler. Then there is the sanity checking, then the performance checking, and the cleanup, which cleans up the resources of the test, which, by the way, have been also created in the setup, some sandbox directories and these kind of things. So usually, I mean, when you submit a job and you execute your test serially, essentially you will be just idling until you get the job back. So the asynchronous execution policy is essentially everything inside the frame is serial, but actually we're taking advantage of this kind of idle times to schedule more work. Yeah, we just pick the other test, start these pipeline stages, and another test, and then as soon as we finish all the test process, then we enter a busy wait loop, and then we just gather the different tests that have finished and continue their pipeline to their end. So the pipeline also gives you also reasoning, you know what is happening. It's not just random, I just got a test. This is the pipeline is just the stages that they have to be respected. So I'm not going to show the configuration file, but essentially the configuration are essentially 3 sections. So you define your systems, which is basically the most relevant information there is that you should define a set of hostname patterns so that you can help ReFrame when you launch it on that system to pick the correct configuration. So you can define multiple systems, multiple clusters inside your configuration system. Then you say which are your module systems that you're going to do, and you attach virtual partitions to the system. So virtual partition is nothing to do with a scheduler partition. It can be a scheduler partition, it may not. For example, you can define a virtual partition that are your login nodes. You can define a virtual partition that's for us is our hybrid nodes, which are not scheduler partitions. They are just obtained through constraints in Slurm. So partition has definition is basic definition how to access this partition, and what are the tool chains that you want to test on that partition. And there are also some other minor options that I'm not going to go through them. And the third thing is the programming environments, which in ReFrame, a programming environment is just a set of modules to load and a set of environment variables to set. You can also set plus the compiler and linker options if you want to, not linker options, compiler and linker commands if you want to do so. So I don't know if you can see that, but this is a simple test that essentially runs a matrix vector multiplication with MPI plus OpenNP. I'm going to go quickly. This is how a full test looks like. So tests in ReFrame are classes that inherit directly or indirectly from this base regression test framework class, and you just have to decorate them spatially. And then you put your description, that's optional, and then the valid systems, this is the systems that your systems and partition that your test is valid for, the programming environments, the tool chains that it should be tried with or it is valid for. This is where your source file is, so, and then it's how you're gonna build this. So here is single source, so that it will just say that invoke the compiler on that source file and create an executable. You can put here make, cmake, autotools, and then it will just emit, configure, etc., whatever is necessary. It's, of course, it's not a replacement, it's never intended to be a replacement of what EasyBuild or Spark are doing. There's completely different scope. Then for each programming environment, that's for that particular, executable options are the options to pass to the executable that's going to be generated. And then you define for the different programming environments the actual flags, because in this case, each one has different OpenNP flags, or you could use other flags as well. Then you can specify the num tasks per node, etc., that will eventually be translated into the job script. Environment variables and the tags. Tags is a way that you can basically tag tests so that you can easily select them. And finally, I didn't talk about this, is the sanity patterns. This is what you want to look at in the output. So ReFrame does not assume that a test succeeded if its exit code was 0. It's always up to the user to specify what a success means. So here is basically this SN dot this one is a library of lazily evaluated expressions. You can combine them in any way. You can write your own sanity functions for a very complex analysis of the output. And the beauty of this is that you write everything in Python. So this is a very grep-like thing. This is the simplest you can have. So okay, look for this in the output, but you can extract a set of values that will get back to you as a list in Python, and then you can take the average. You can do whatever you like. And finally, here there is a small function here in this one. Let's say it sets flags. It's an arbitrary name, and actually sets the C flags for the build system based on the current programming environment. And this is a new feature, like two versions ago, that we've introduced, that you can use like decorate arbitrary methods of your test and attach them before or after the pipeline stages. So this, you say, okay, you should execute this function just before compile. And I'm going to, how is the performance test like? I'm going to skip all the common part. There are two key differences in performance test. You have to define performance patterns, where you have defined a performance variable and an expression on how to extract that performance variable from your output or from a file or from whatever you want. And then there is a reference dictionary where you mention your systems as keys, and then the performance variables for each one, and then a tab specifying the reference value, the plus minus, the tolerance, and the unit. And actually, all this, when the test is run, is going to be fed to the performance logging. So the actual value that was obtained plus the reference plus the unit. So then you can use the information to do plots and and process it. That's another cool feature from, it's kind of brand new, test dependency. This is a test that we just have it. It doesn't look any meaningful except just to test the dependencies. It's taken from a thing that we're running in the unit test. So essentially here is the test. What it does is writes in its output. So before the run phase, essentially it runs, it executes. No, it runs on its output. Sorry, it extracts this number from the name. So the T0 here, this ID, and writes it to a file. And then the dependent tests just should read from their parents that ID, do an operation, and write that down to their file. So then you can build a complex graph, and if it's not built correctly, then you can get it. But it's just a demo here. In the tutorial, there is a more meaningful thing about the OZU test. So here again, you see the decorators. And the other cool thing is with ReFrame, you can just structure your test as you like. So here is, you have a base test, and both this test and this test, they're inheriting this. A cool thing is that also those decorators are inherited. So this write count will be also run in T0 and T4. And then you put the depends on, and actually that depends on the T0. And then you have a function, you call it as you like, and then you say, okay, this function requires the dependencies. Which are the dependencies? So the T0, and you can put more here. Actually, there is some merging here happening to this argument, and then you can essentially call this, like T0, call it, and then you can retrieve the actual instance of your parent. So then you can access its stage directory, you can look at the files it produced, and then you can use that. So, and then the runtime will take care of not only scheduling the test correctly, but also cleaning up the resources. Because if I have dependent tests, I don't want to remove my directories because my dependent tests might need my data. So everything is handled by the runtime. And you can also have a finer grain control over the dependencies, but I'm going to skip that. So this is how the output looks like of the CUDA test that I've shown before. So the tests are run, then they're waiting for the spawn checks to finish, and the ReFrame will print a small report. Here is an example failure. If something fails here, you get a report, and you get where it failed, with which programming environment, where was the stage directory. There you can go into that stage directory, and you can find the job script generated, the build script generated, so you can reproduce completely what ReFrame did. And that's quite important when you have to deal with vendors where you can't give them a ReFrame test, but okay, I'm just going to this directory, I'm just starting it, sending to them, that's your use case, this is failing. It's failing to compile, because there you have everything, the module loads you did and everything. So that's the failing phase, the performance, and there a small message. Now, about performance logging, I talked about this before. So whenever a performance test is run, and the performance test is in ReFrame is a test that defines these perf patterns that I've shown before, the performance can be logged through different channels, normal file, syslog, graylog. And the cool thing is that some sites, they use syslog and they send syslog to Elasticsearch, so then they can view along the historical information about the performance. We send directly to graylog from ReFrame. And here is an actual, the performance of Gromax GPU version over the last month. And we can visualize that on Grafana. So this is how we have set up ReFrame at CSCS. So we have the ReFrame repository, which is a public one in the test, and we have a private also test repository with some tests that we don't want to share. So we have a Jenkins that actually pulls both. This is scheduled daily, and it runs on the different systems. Now it's Pittsdale, this is the Meteo Swiss, and we have the new system of Meteo Swiss. Luke is gonna talk more about that. That it logs in, Jenkins logs in there, and launches ReFrame, and then ReFrame sends the through Greylog to Elasticsearch. And we have also set up Jenkins so as to notify the roster if the daily regression fails. It opens a ticket to our ticketing system, and the roster should go and have a look whether this was a transient failure or it's something more serious. Regarding the tests, we have several categories. We have what we call Cray PE tests, that they just test the programming environment functionality from Cray, no software stack from ourselves, just what Cray gives us, because, yeah, believe me, it's not well tested by them. Production tests, where we test our entire HPC software stack, both for performance and functionality. Maintenance test is a subset of the previous test that our operation team runs before and after maintenances, and we have also a separate set of benchmarks. We have 534 tests in total in 90 test files. Now, imagine that these are tests. So you have to multiply it with the programming environments and the partitions that you're running them. So this can blow to thousands of test cases. So you have a good coverage. And some experience from last upgrade to the latest Cray Linux environment, which happened, I think, before supercomputing. The key lessons is, in that thing, we enabled ReFrame the first time that operations gave us the system with a new TDS, with a new CLA. The first thing we ran, even if we didn't have our software stack ready, to have ReFrame run there. And that was quite good, because very early in the process, we discovered lots of regression from Cray side. We had to open like several Cray tickets. And then if you have a lot of tests, then it really builds confidence at the end when everything is green. And actually, after that, we just have two problems, tickets with users reporting tickets from a change slurm variable name that we didn't test. And I don't remember, and another one, which I don't remember very correctly. But imagine giving the system without testing with such a major upgrade. It would have been a nightmare. So this is a bit of the test. You can find most of them inside our repository here, the CSCS directory. We have HPC applications, libraries, programming environments, Slurm tests, performance and debugging tools, I/O tests, micro benchmarks, container runtime checks. That's in a private repo, so you won't find them. OpenStack, some OpenStack S3 API tests. Now I'm gonna go very quickly to some user case of other sites. So NERSC, NERSC in Berkeley, they have gone fully with ReFrame in production for their system, and they use it for software stack validation and for performance testing and benchmarking. They're actually now moving all their old benchmarks into ReFrame. And one cool thing is that they also feed their performance data through syslog, and then from syslog to Elasticsearch, so they can have from ReFrame performance data. They can, the managers can visualize the live data from ReFrame when it runs during the day, and actually they have also integrated with a GitLab CI/CD solution that is currently being developed within the Exascale computing project in the US, a big project with big procurements. So they're testing their software stack through GitLab, and then they launch ReFrame from within GitLab to test the software that they have built. Then it's Ohio Supercomputing Center, also in the US, that they are doing software stack validation. Again, they have integrated with CI/CD, and again, they're using syslog, and then from syslog with Splunk, they feed the performance data of ReFrame to dashboards. And there are two papers, one we presented with both NERSC and the OSC guys at HAST in supercomputing. I think it's in the process of being published in the proceedings of proceedings. And this is also a nice paper from the guys from Ohio in last year's PERC conference. And I know there's also other sites that I know they're using or experimenting. POS in Australia, they have it in production. The new one in New Zealand, where they at the Weather Service, they have it in production. I was talking to Surfside people that they were experimenting at least. There's another company in the Netherlands that they have even contributed the BPS Pro backend, the ASML that they're using it also in production. There are many more sites experimenting at least. And now I might be out of time, but okay, so I'm finishing. So this is a nice work we started with Kenneth. So Kenneth wanted to use ReFrame to test EasyBuild. So the idea is that to create a ReFrame test for each EasyConfig file, and then have ReFrame schedule all the tests and basically make sure that the compilation works for each EasyConfig file. So the key concept here is the dependency graph is generated on the fly before the ReFrame test using the EasyBuild API. So then it gets essentially the graph, and then it uses a parameterized ReFrame test, which I didn't show before, but it's you can find the documentation, to actually generate tests for every EasyConfig file, and then you have ReFrame run this graph. So actually here what Kenneth does is EasyConfig test, it's a parameterized test over this test, which is essentially tap the name, the EasySpec and the test dependencies, and in his test says for each of the dependencies, just create the edge in the dependency graph, and there it is. There is a full code snippet here. I'm going to share the presentation so you can just click on that. And finally, what we're planning to do for 2020, we want to redesign the configuration component. We want to introduce a bit more, a newer, not substantially different configuration syntax, but the new syntax, we're going to give you more control on the different aspects of the framework. I want to support multiple configuration formats, and enable also configuration through environment variables. We're going to have a conversion script from the old configuration syntax to the new one. So if you're using ReFrame with the old configuration syntax, this is going to be automatically converted, so don't worry. We want to improve documentation with targeted tutorials for EasyBuild and SPAC installations and Cray system, because our tutorial is essentially tailored for our Cray system. Because we tested also there that the tutorial exams work fine. And some people, they think that it's very Cray specific, the tool, but it's not the framework. And then we want to investigate ways of further facilitating the porting of tests. Currently, you have to always, not always, you have to tweak the test, like add a new system in the valid system or a new programming environment. We want to find ways to avoid this. But this is at the thinking level. And finally, bug fixes and user feature requests. And we're planning to call this release ReFrame 3.0. We have accumulated lots of cool features the last year, like the dependency, the container support, the benchmark report, which I didn't talk about. And we have a project with the issues that we want to address for this ReFrame 3.0, so you can have a look. And we're going to do, usually we do every 2 to 3 weeks a development release. And yeah. And yeah, concluding, I do believe that ReFrame is a powerful tool that allows you to continuously test HPC systems, because it integrates very well with CI/CD workflows, gives you comprehensive reports and reproducibility. That's quite important. It's a single way that nobody does its own way. It's the ReFrame's way, how the scripts are produced. Portability across HPC system platforms, and you have all the power of a high level programming language. And you lose some things that you get in a YAML configured test file, but you gain a lot more. So I think the learning curve is the same. And yeah, here is our GitHub repo. And yeah, there is an effort. If you have ReFrame tests, just share me, and you have them in a public repo, you can just share the link or send me the link of the repo, and I will populate it. I will fork it and mirror it under ReFrame HPC, so the different sites, you can pick tests from different sites. So that's it, and yeah, I'm sorry I've run the time, but.
Thank you. Very nice presentation. In the list of the software, taking account that you are in CSCS and working with Meteo Suisse, are you using ReFrame for Cosmo?
So, for the Cosmo, there is one fundamental issue to solve before moving into ReFrame. Have you ever tried to compile Cosmo?
No, but I can imagine in the line that you were saying the way of compiling, I imagine that it would not be easy.
No, Cosmo is a beast. And actually we have, I mean, that's also, perhaps that's one of the, Kenneth, you should use a use case. We managed to compile Cosmo and its dependencies with EasyBuild and deploy them. And now we're trying to convince Meteo Suisse to, guys, use our recipes. At least when we're doing upgrades, we are using EasyBuild to test the Cosmo and build its dependencies, because otherwise it's a nightmare. In their build scripts, they're doing module loads, they have hard-coded paths, it might replace your Wharf example, I'm sure. So the idea is that, yes, we have a test in ReFrame for Cosmo, it's in a private repo, that actually runs a pre-built binary. And then we do a very thorough test of, we're running the unit test, not unit test, the testing suite of Cosmo from ReFrame. And then because they're very strict sometimes with the bit reproducibility, so in their suite, yeah.
This
so
was
they
my
have the
second
match
question.
versus okay and these kind of things. We have a test that actually is very, a guy from our unit has written a test with his own sanity, big sanity function that is very, very pedantic and checks everything from Cosmos output to check that even not a match change to OK and this kind of things.
Yeah, because then there is the way how you validate a result, because you don't have, you are not looking for bit to bit, but you are looking for something statistically.
If you're interested, you can contact me and I can send you
later because
the test perhaps. Because the idea is if we have a module for EasyBuild, for a SPAC or EasyBuild module of Cosmo, then you can just say in self.modules, there is a thing inside ReFrame, you don't have to build self.modules, load the module Cosmo. And then you have the same test that you had before, so yeah.
Yep, I was wondering, what is the use case that you see for these test dependencies? Because I don't immediately see it.
Yes, good question. And in the tutorial, we have a nice use case. So imagine you have to download and compile some benchmarks, like OZU benchmarks. I know already some sites, they always compile the OZU benchmarks. So if you didn't have dependencies, then every test you would have to compile those benchmarks and now run the bandwidth, run the latency. Now in the tutorial we'll see there is the OZU build test, which essentially downloads and builds it, and all the other tests that they depend on that and that they run. And another use case which is quite useful is to do scaling tests. So you can have one thing for an you're developing your application, for example, and you can have a ReFrame test for that and do scaling tests, for example. So you can run a base build test for your application, and then you can have a parameterized test over the number of tasks we want to do, that they all depend to that. And yeah, these kind of things.
Okay, and if I may, I have another question. Do you version the tests that you publish on the public GitHub? I don't know if you ever change them. I mean, I can imagine you push some updates when the syntax changes, etc.
Yes, so our tests essentially are in the same repo as ReFrame, so they're tagged with every ReFrame version. So we don't have, we had the discussion like before going public whether we want to split the repos, but said we're gonna go with one repo. It could be easier at the beginning. I mean, if people adopt it, and then we can rethink it. But the idea is that it's easier to onboard people if they just see the test. But
yourself, yeah. I know.
Yeah, you can have your own repo. That's the thing. Everything is from the command line. You can point to your own tests, to your own config file. So that's possible.
Question back.
Hello. Do you think ReFrame could be used as a framework for doing general benchmarking as opposed to benchmarks as part of testing?
Yes. So I know several sites, they want to, one of the primary reasons of using ReFrame is also benchmarks, because as I've shown before, you can use this syntax. You can, it's quite flexible in the way you extract things. You can have something that reports several performance numbers in the output. You can just in a single test extract all of those performance variables and then report. We have several benchmarks, and actually the performance logging feature is quite powerful as well. So it feeds the data. You don't have. It's up to you whether you want to feed it to a file and then plot it yourself, or just feed it to a more modern thing and have your dashboards. That's certainly a thing we are doing, and I know other sites are doing so. And you can. I know also that other sites, they want to use ReFrame for acceptance testing. So the idea is, for example, at NERSC, they integrate all benchmarks, and then when they get a new procurement, to just launch the test with ReFrame. If everything is green, that's a good sign.
So how do you deal with, so some tests might actually need input data, and regarding especially sharing those tests, so how do you deal with
good
getting
question.
input data?
So one thing I didn't show, and I should have perhaps, is what is the structure of a test. So apart from the Python file that I showed, there is in the directory where this file resides, there is an SRC directory, or you can name it, but by default it's SRC, where inside that there are the resources of the test. That means the input files, etc. All this directory is copied over to the stage directory of ReFrame, and then the working directory while running your task is that stage directory. Now, for our tests, because of size, some we haven't put all the input files, especially from some applications, on GitHub. But you can. One thing you can also do is there are pre-built steps that you can actually wget something if you have them somewhere else, or you can also git clone from a repository and this kind of things.